Welcome back. In this video we will hopefully repair this Sonos Sub Generation 1. A few weeks ago I teared down that thing which was dead as a dodo, and we did some failure analysis and found that the switching power supply was completely dead. At least two burned out resistors, shunt resistors, one exploded SMD diode, and the switching MOSFET here on the primary side failed in a kind of a short mode, which all led me to believe that there are probably more defect parts here which are not exploded. So they might look okay, but they are probably defect, destroyed, dead. And without a circuit diagram, repairing this power supply is probably not worth it. However, we also tested if the rest of the board, the analog board and the connected here digital board survived. And indeed, at least the digital board is still working. We injected here 48 volts, I think, DC into some test points here. And we could connect with that thing via Bluetooth and Wi-Fi, and everything seemed to be fine. So I came up with a proposal. And by the way, card to that teardown video and failure analysis here and link in the description. So I came up with a proposal to completely replace that power supply with a off-the-shelf unit. And that's what we'll try in this video. Enjoy! I'm estimating that this power supply unit here delivers about-ish 180 watts, just from the AC input values here. And I proposed in the aforementioned video that we just take a standard industrial switching power supply, 102 by 51 millimeters, so 4 inches by 2 inches, and place it somewhere here on the board after we depopulated all that. And I think I even suggested we could use a CUI VOF-180 for 180 watts, a C-48, which was listed on DigiKey as a 180 watt 48 volt power supply. 180 watts without active cooling. However, that turned out to be wrong. These small power supplies cannot supply 180 watts without at least having a little ventilator, little fan. And that's not something that you can really build into a speaker, can you now? The problem is the next bigger size of standard switching power supplies. That would be 5-inch or 127 millimeters by 4-inch, 76 millimeters. There's no way that we can fit that here onto the board, or even if we would saw off the board, there is no space for that. That housing, speaker housing, is cramped. So we will compromise and take whatever that power supply can deliver without active cooling. And if you look at the height profile of the original power supply and our off-the-shelf switching power supply, that should actually fit very nicely. The reason Sonos was able to get 180 watts, or I'm assuming 180 watts, out of this small space here is that they simply were able to design an odd PCB shape here and spread the thermal loads across it. So and in comparison, that switching power supply really has only one central heatsink. So yeah, an advantage if you can make your own custom power supply with a form factor that actually fits your housing. But we don't have that luxury. We have to use something like that. I didn't choose this power supply nilly-vanilly. It had to fulfill some requirements. The first one being, of course, it has to be certified. So, by the way, I would never buy that for this kind of application from Amazon, eBay, or AliExpress, or whatever, only from a reputable electronics distributor. And then, of course, input voltage range, 230 volts here in Europe. Then it must be suitable for class 2 installations. That is a device that does not have a mains earth connection, just a 2-pole plug for mains AC. And the usual overvoltage protection, overcurrent protection, and short circuit protection, but more importantly here, over temperature protection. Yeah, we put that in a basically closed housing, and things could get toasty, and I don't want that thing to burn up, but to switch down in a controlled manner if it gets too hot. Also nice, you can adjust a little the output voltage up to 50.4 volts, which comes quite close at the original 52 volts the original switching power supply puts out. Not really a requirement, but something you have to check with these things is the output capacitance they can drive. And our 48 volt model can only drive an output capacitance of 1600 microfarads. Meaning these two 1800 microfarads, so total of 3600 microfarads filter capacitors here on the secondary DC side have to go. But I have something else in mind here to get the output noise a little bit down. And here comes the usual read your data sheets until the very end advice. So we find here on page 4, I think, derating curves. And here you can see that 100% of output power is only possible with at least 13 cubic feet per minute airflow over that thing. If we have only natural convection for the 48 volt model, you only can get out 62% of the max power up to 45 degrees. And from there on, things just get worse. 62% are still 110 watts, which should be for normal operations, yeah, if you don't go to 11, enough for that subwoofer. Finally, on page 5, we get the hint that, probably too small to read on the screen, but anyway, there it says, Class 2 systems, 1 and 3 positions must be connected together. So these two holes here, there has to be electrical connection between them, so this thing really works in a Class 2 system. And now let's depopulate the primary side of the power supply. I can't promise you anything, but I'll try to keep inside the frame while removing all these components, and I will just give you a time lapse, okay? So that cleaned up actually quite nicely. And I left a few components on there. Starting with that filter capacitor here, which actually belongs to the low voltage side. Some discharge capacitors here on the high voltage side. Plus the input fuse, the first filter capacitor and the first common mode filter and the MOF, and I think that's even a temperature fuse or something like that. Some more filtering here on the low voltage side, directly on the transformer output. I'm not sure if that's really necessary. That's probably just to remove spikes, but since we removed the major filtering here, the big two electrolytic capacitors, we take any additional filtering we can get on the DC side. And that was actually part of the voltage feedback for the voltage regulation of the switch mode power supply. I removed the optocoupler here that goes from the low voltage to the high voltage, but I left that circuitry here that's driving the optocoupler in place, because we have here some traces that lead somewhere. So I don't know if the whole thing would be really happy if we removed all that. And now we have almost enough space to put our little replacement power supply here. And I have no qualms to drill 2 additional holes here into the PCB. If we break some traces, it really doesn't matter. If we create a short between mains neutral and mains phase, that will be a problem. So we have to check for that. But again, just drilling through here is okay. On that side, we're a little bit, going onto the low voltage side of things, and we can definitely not put a hole in here, and shouldn't probably put a hole in here. So instead, I will create some kind of bracket that we will mount here on these 2 points, which were usually holding up the heatsink for the rectifier diode. Okay, let's search now for 2 good connection points here for our mains AC input. And I replaced here, put just here the placeholder. So let's see, this is dead, this is dead, this is dead, this is dead. Interesting. They are all dead. Then this side. Okay. So here we have 1 line for mains AC, and this should be the other line. And there's no short between them, at least not in the moment. So these 2 connections for AC. I have here still on the back side that cable here connected to the DC output test points. So, now I want to have a ground connection somewhere, and there is a ground connection. Oh, come on. Ground connection. Okay, that was probably just a capacitor. Okay, this is ground. That's not helping really. Everything else will be... Okay, ground is here. Well, you can actually see it. Can you see it? Let me zoom down. Yeah, this is actually very visible. The big ground plane here. Am I in focus? Here we are. Yeah, you can see the ground plane. Okay, but that would be below my supply. That's not good, is it? No, not really. What shall we do? Zooming out again. Okay, let's say I have 10 millimeter spaces here. I can still work with that somehow. And then the positive should be one side of these diodes. No? That's disappointing. I could have sworn it. I mean, that was the rectifier diode. So here we have positive. Now is something funny going on here, and maybe I have to do a little bit of reverse engineering. I mean, we could always go for the on the other side of for the test points, but I really would like to feed in my DC where the output of the transformer was. Give me a sec. Okay, that was kind of fun. So it's an interesting circuit. So the secondary side of the transformer has two coils, okay? And one coil, or one end of one coil, is the connected to positive, and the other end of the other coil is connected to ground. And between them we have, first filter capacitor here on the back. I would say a rather large ceramic type. And then the over cross here, both coils, or between the coils, we have our rectifier diode. And parallel to the rectifier diode is a little snubber circuit, probably to keep any high spikes, voltage spikes from the diode to ensure its survival. But in the end, that means I can feed DC ground in here and DC positive in here, and these parts are also, well, obsolete. They don't do anything. I will remove them real quick. And now for the bracket. I need that about 7 centimeters long. That should be okay. And we will make it 1 centimeter wide. That should be okay. And height. I will use on that side 10 millimeter standoffs. And I need 2.5 millimeters here to avoid these pins, so it should be 7.5 millimeters thick. Okay, let's do that. So let's get ourselves a slice of POM, 7.5 millimeter thick, and these are leftovers from my previous project card here, link in the description. 7 centimeters long and roughly 10 millimeters or 1 centimeter wide. And I need a little relief on one side for the parts that are still on the board. I cleaned out the rest of the cutout here with the file, and I already marked the 2 holes for mounting that thing here where the heatsink was. Little detail I almost overlooked, that little hole has to be free, of course, so we can still screw the mainboard back into the housing. Now let's mark 2 holes here for the 2 standoffs on the AC side of our new power supply. I'm trying to align that here as accurately as possible. Well, Good enough. Let's drill those holes then. We first go in with a 1.5 millimeter diamond drill. And then we follow up with a 3 millimeter normal spiral high-speed steel bit. It would be negligent if we didn't check if we still have isolation on our mains neutral and mains face here after we drilled the holes into the board, but yeah, everything is fine and our other connections are also still there. Perfect. I loosely mounted two standoffs here just to see if everything fits, and yeah, looks good. Two more 2 millimeter holes into our bracket. And those have to be countersunk for M2 screw heads. I mounted the bracket on the board and now we can test fit our new power supply. Just with two M3 screws, nylon of course. We want to keep everything nice and isolated. Almost good, and now I can mark the holes for the last two mounting points here on the bracket. Those holes will be drilled for M3 threading with 2.5 millimeters. And then the M3 threads are cut. Since I started by accident with the 0, doesn't matter. As long as my screws fit in here. And yes, they are. I mean, we're not cutting aluminum or steel, we're cutting here into POM, which is a pretty resilient polymer, but yeah, it's no metal. Everything's fine. Perfect. Okay, I reattached our bar here, our standoff, and now let's dry fit everything one last time. Wonderful. Now we need three cables. We need our mains AC to go in here. Then we need our DC to go back there. Yeah, we marked that holes. And then since we have a class 2 system here, so without a mains earth connection, we need to connect 2 pins here on the board somehow. I have to look into the data sheet again. But before that, we have a little sanity test if we are not building too high anywhere. So this is one of the output filtering capacitors, and yeah, there's enough space. And this was one of the common mode chokes here. Yeah, let's put it up that way. So yeah, we're also at that height here. Oh, this is a little bit higher on this side, but it should be okay. It should be okay. Because we also had these capacitors. Yeah, also maybe 2 millimeters missing. We will see. We will see. If not, we have to take everything 2 millimeters down, which would be a mess, so let's first try it this way. I made a nice little cable here for the AC connection, these two holes here, and this should, in theory, fit after I soldered it in just perfectly. Give me a sec. Side note, I used here 90-degree pin headers, okay, at the end, so I can really join that nicely here into the PCB. Yeah, that looks good. Wonderful. And I did the same for the DC output, so I hope I will get somehow rid of the cable. We will see when we try to get the whole thing back in. Anyways, I'm using here 1.5 square millimeter cable because, yeah, it's not that much current, okay? So about 3 amps, but nevertheless. Here's the final piece of the puzzle, that connection from mounting point 1 to mounting point 3 according to the datasheet. We saw that in the beginning, and that will just loop around somewhere here. Please note, these 2 points here are not, they are isolated. They are not really connected to anything, but for some capacitive coupling here. And the whole idea of that connection is to keep down the electromagnetic emissions, the noise. Everything is mounted nicely now, and I made all connections but for the DC connection to the existing circuitry. We will do that after a test and some adjustments. And yeah, we also have a nice air gap and ventilation on the back of our new power supply. That's also important. There are active components down here. So, let's test that thing. I'm feeding in 230 volts AC from my isolation transformer, just for security reasons, here at the original connector, and that should go into our new power supply. And then I'm just measuring for now the output voltage from the power supply. Let's see. So 46.4 volts, that's adjustable. There's a little pot here on the low voltage side, and we should be able to, turn up the volume to 51.37 volts without any load. And as you might remember, the internet says the board needs 52 volts. So we're quite close. We're quite close. I'm happy. I removed my DC injection cable from the test points, and now as the last measurement, I'll put some, hopefully that will work, some Loctite here on the screws, just to be on the safe side. And we will let that cure and do that from the other side too. Remember, this is a subwoofer, so there will be some vibrations. So you better glue down your screwed connections. And we do the same on the other side, just applying some dabs. That was wrong. Just applying some dabs of Loctite here at the edges. I guess you could use some hot gunk if you wanted to, but yeah, that's good enough. Now let's see if we can actually fit our board back in here. It's a tight space, so this way around. These are speaker connections, and yeah, let's first do the speaker connections here. So this goes here and this goes here. That's good. Then we have our AC mains input. I'm a little bit out of frame, sorry. That's there too. Now I have to work a little bit around the camera, but that's okay. Everything for you. I'm searching. This goes here to the speaker, and I'm almost in frame. And now I have to walk around the camera. The speaker connection goes here. Yeah, they fit, and that's the connection to the digital board, which is not secured at all. There's a lot of hot gunk here on the board, but for that connection. It's in two. Now let's see. Something's in the way of success on that side. Trying to determine what it is. It's our grounding cable. Almost. Yeah, our grounding cable, unfortunately, is in the way. And I'm trying to fiddle that below the mounting point on that side. Okay, managed that. That's good so far. Now everything should be going here down too. All mounting points are sitting down. Wow. Yeah. Did I mention it's a tight fit? Yeah, I did. I'm a little bit out of frame. Okay, that's better. I'm not happy with that screw. Okay, that's better. Okay, wonderful. And now for the reassembly of the rest. Next is the wood particle board, and I actually had to refer to the tear down video. So that arrow points up. And but you could put it in theory both ways, and yeah, this should be these normally threaded screws. Yeah, looks good. Okay, and there are 4 more self-tapping countersunk screws at the center. Now for the front plate, or however you want to call that, there is actually, you can't barely see it, but there is also an up arrow here, and you're actually not able to put it in the wrong way around. So that just presses in. And then we have 8 threaded screws here at the center. And now for that dreaded anti-repair measurement here. Yeah, I just bend it a little bit back into form as good as I can, and then we just press it on. I have no idea if that will stay on or if it falls off when the music plays, but certainly not adding additional glue in case we have to repair that thing one more time. Or maybe if it's not running after all, I don't want to go through the hassle and completely, destroying it again after putting it into form. Well, it's not perfect, but it looks good enough, at least from a distance. And now for a test. Okay, let's test this thing. If I plug the power in, nothing explodes and the light comes on. Wow. And now it's blinking. That is, it's searching for some Sonos stuff, software in your wireless LAN. Let me get my iPhone out. So the blinking of the light has stopped because, can you read that? It's in German, sorry, but I found the sub, and in theory I should be able to switch off the light. Ooh, that's cool. Okay, so at least the digital part is working. We knew that from the first video. And hopefully the analog part, the amplifier itself, survived our high energy event in the power supply. But anyway, I cannot test the sound itself because you need a complete Sonos setup for that. Just the subwoofer won't work. So I will get that back to my friend now, and he will tell me if the repair was actually successful. But I am very hopeful. And that was the Sonos repair video. Repair. Please keep in mind with that little off-the-shelf power supply we put in here, the output power of that subwoofer is limited to 60% of its former glory. But anyway, I can't imagine anyone really turning that up to 11. And because 180 watt subwoofer power, that's a wee bit much for my taste. And now we are down to 100 watts. So still enough, I guess. Till next time, bye.